Welcome. Today we will see chapter number 1, that is Introduction to Control System. Now in the slide you are seeing that a lamp is there and switch is there, and also second image is of traffic signal. Therefore you are knowing that with the help of switch we are controlling on off function of the lamp. Also these traffic signals are there. We are knowing that traffic signals are used to control the traffic on the road. After each and every 1 minute, this first of all green signal will be there, then yellow signal will be there, then red signal will be there. Therefore, these are nothing but control systems used in our day-to-day life. Now, contents of the chapter. First is the introduction to control system. Second, need for control system. Third, manual and automatic control system. Fourth, open loop control systems. Fifth, closed loop control systems. And sixth, modern control systems. Now we will see introduction. A control system manages, commands, directs, or regulates the behavior of other devices or systems using control loops. A control system is one which can control any quantity of interest in a machine, mechanism, or other equipment in order to achieve the desired performance or output. A control system is an interconnection of components connected or related in such a manner as to command, direct, or regulate itself or another system. Now in the block diagram, it has been shown a sample control system. Input is there to the process, output is there, then output is compared with the input, then again feedback signal is given to the input, again process is there, again output is there, again feedback is there, feedback is fed to the input unit. This process will continue until input is equal to output. This is known as control system. Now we will see certain examples. For example, consider the driving system of an automobile. Speed of the automobile is a function of the position of its accelerator. The desired speed can be maintained or desired change in speed can be achieved by controlling pressure on the accelerator pedal. This automobile driving system, accelerator, carburetor and engine vehicle constitutes a control system. Now we are knowing that we are driving the vehicle. We want to achieve certain speed. If suppose we want to achieve 40 km per hour speed and initially our speed is 20 km per hour. Therefore what we are doing? We are increasing our accelerator. Increasing our accelerator means what? We are supplying more amount of fuel to the engine. Therefore speed of our vehicle will goes on increasing and speed will reach to 40 km per hour. Then we will stop accelerator at that position. Similarly, if suppose load increases on the vehicle, therefore when the load increases, its speed will decrease. Therefore at the same time again what we are doing? We are increasing again accelerator, that is we are supplying more amount of fuel to the engine and again we are reaching up to the 40 km per hour. Therefore this is known as the control system. This accelerator is nothing but controller, speed controller of the vehicle. Now we will see why there is need for control. Control systems find numerous and widespread applications from everyday to extraordinary in science, industry and home. Here are a few examples. Consider a fan. Now we are knowing that in each and every house or everywhere, in shops, everywhere fan is there. Now you are knowing that fan is controlled by using regulator. On the regulator there are 4 speeds. Speed number 1, slowest. Speed number 2, just greater than speed number 1. Speed number 3, just medium speed, and speed number 4 is the fast speed. Therefore, by using the regulator, we are controlling the speed of the fan. Now you just see, fan with blades but without regulator can be a system, but it can provide output, that is airflow. But it cannot be a control system because it cannot provide desired output, that is desired flow. That means if regulator will not be there and only fan is operated by using button, therefore fans there will be only one speed of the fan, only fast speed, and once you will switch off the button, fan will get switch off, that is speed of the fan is reduced to 0. Therefore a fan without regulator can be a system because it can provide output, that is airflow, but it cannot be a control system because no regulator, or we cannot control the speed of the fan. Therefore fan with blades and with regulator can be a control system because it can provide a desired output, that is controlled airflow, just previously I explained. So for desired output, a control must be there on the system. Again, we are knowing that we are using air conditioners to cool our rooms or halls or whatever it may be. In vehicle also air conditioners are used. Therefore, these air conditioning systems are controlled by a thermostat. Similarly, the speed control of an automobile. We are knowing that just now I have explained that if load on the engine will increase, speed of our vehicle decreases. Therefore, in order to maintain constant speed, we have to supply more amount of fuel to the engine. Therefore, our vehicle will run at a constant speed. Therefore, this is known as accelerator, is known as speed controller of the automobile. Similarly, we can see a manual control, opening or closing of a window for regulating air temperature or air quality, activation of a light switch to regulate the illumination in a room, human activities like controlling body temperature, etc. Now, these are some of the examples of why control system is needed. Now we are knowing that in city, traffic control system is there, that is signals are used to control the traffic on the roadways. Similarly, in the guiding missiles, we are knowing that whenever we are launching any satellite in the space, a control system is used so that at every stage that fuel ignites and it gives power to the engine, and that satellite can be placed at a specified orbit. Similarly, in manufacturing processes, control systems are used, that is CNC, computer numeric control. In case of computer numeric control, whatever dimension, suppose we want to achieve 25 mm diameter from 50 mm diameter shaft. Therefore, every time when that tool takes cut, every time feedback is given to the tool that still the diameter is 30 mm, then again feedback is given to the tool, then again tool takes the cut. Therefore, tool will take the cut until the shaft diameter reaches up to 25 mm. Therefore, this is known as the control system or feedback control system. Now we will see basic components of control system. First is input. The stimulus or excitation applied to a control system for an external source in order to produce the output is called as an input. For example, a switch to blow lamp. Switch is known as input. Next is output. The actual response obtained from a system is called as an output. Therefore, whenever we are providing input, some output is there. Therefore, glowing of a lamp after switch is made on. Therefore, glowing of lamp is the output. Next, system. A system is an arrangement of or a combination of different physical components connected or related in such a manner so as to form an entire unit to provide certain objective. Therefore, in case of system, some input is given to the system and from the system some output is there. Now again, these are some examples of a system. A fan without blades cannot be a system because it cannot provide desired or proper output, that is airflow. Fan with blades but without regulator can be a system because it can provide output, that is airflow, but it cannot be a control system because it cannot provide desired output, that is controlled airflow. That is, with the help of regulator we can control the speed of the fan, and that's why that regulator with fan is known as control system. Now next component of control system is controller. The element of the system itself or external to the system which controls the plant or the process is called as controller. For example, on-off switch to control bulb. Now in this image you are seeing that on-off switch is there. With the help of on-off switch we can control the glowing of the lamp. This is there in this example we will find everywhere. In case of tube light also we are using on-off switch so that tube light can be made on, tube light can be made off. Now we will see basics of control system. Finally, we can define it as to control means to regulate, direct or to command a system so that the desired objective is attained. Combining above definitions, therefore we can write system plus control is equal to control system. Same is written in the block diagram. Input is there, control system, output, again output is fed back to the input until the system will run until output is equal to input. Control system is an arrangement of different physical elements connected in such a manner so as to regulate, direct or command itself to achieve a certain objective. Now we will see manual control system. Now in this image we are observing that one tank is there. In the tank water we are filling and a man is there who is controlling the water level with the help of valve. Therefore, consider an example as shown in the figure. A manual control system for regulating the level of fluid in a tank is done by adjusting the output valve. The operator has to view the level of fluid through a port in the side of the tank. Accordingly, if water level rises or falls below the desired level, he has to operate the valve. Therefore, here human interface will be there to control the height of the liquid in the tank. Now we will see automatic control system. Similar application can be controlled automatically as shown in the figure. Now you just see in this figure, here float is there, water level is there. Suppose if water level reaches to the desired height, what will happen? This float will raise and then this fall will go down so that water coming inside the tank can be restricted. Therefore, this is known as automatic control system. Therefore, same has been explained here. A control system for regulating the level of fluid in a tank is done by adjusting the output valve. The automatic operation is done by operating the valve to maintain level of fluid. Accordingly, if water level rises or falls below desired level, automatic operation of the valve takes place and water level is maintained. Therefore, see this automatic control system. This tank is there. Here input water is there. This float is there. If suppose water level rises, therefore this float will also rise. It will give signal to the controller. Then again controller will give signal to the valve. Suppose if desired level reaches, this valve raises, it gives signal to the controller and controller gives signal to the valve, and automatically the valve comes down and water input to the tank is closed. Therefore, same has been represented in the block diagram. What is our target? That is desired level, that desired height of the water, controller, pneumatic valve, water tank. Again from the water tank signal we are taking from the float is giving signal to the controller. Then again whatever, when the desired level is equal to our actual level, then controller stops the input of the water into the tank. Therefore, this is known as automatic control system. Now, what is meant by manual and automatic control system? What is the difference? Now, in the diagram, already we have seen the example of controlling the water level in the tank. That is also that we can take as a difference between manual and automatic control system. Now, suppose water temperature. Take another example. This man is there. Now he want to bath. Therefore, here two inputs are there: hot water, cold water. And suppose man has to take a bath with the water. Suppose that water should be at 40 degrees Celsius. Therefore, every time that man has to operate the valve, he has to check the water temperature, and then he will take the bath. Therefore, this is known as manual control system. In case of automatic control system, here thermocouples will be there or sensors will be there. When the water temperature reaches 40 degrees Celsius, automatically the supply of hot water and cold water will be adjusted and we can take the bath. Therefore, classification of control system. There are two types of control system: open loop control system and closed loop control system. First of all, we will see open loop control system. Now, open loop control system, a system in which the control action is totally independent of the output of the system, is called as open loop system. A system does not have feedback is an open system. An open system normally works once and then stops. Means, in case of open loop control system, there is no feedback. Input is there continuously and afterwards we are getting the output. Where output cannot be controlled in case of open loop control system. Therefore, block diagram is there: reference input, controller, process, and then controlled output. Now, some examples of open loop control system. A digital camera is used to take a photograph. It is transferred to the computer while processing of the picture takes place and finally a printout is produced. This is an open loop system because there is no feedback and no attempt is made to improve the picture. The person taking the picture decides to improve the final printout using graphics software. Now, these are again some examples of open loop control system. Electric hand dryer. Hot air comes out as long as you keep your hand under the machine, irrespective of how much your hand is dried. Similarly, automatic washing machine. This machine runs according to the preset time, irrespective of washing is completed or not. Another example of open loop system: bread toaster. This machine runs as per adjusted time, irrespective of toasting is completed or not. Then automatic tea, coffee vending machine. These machines also function for pre-adjusted time only. Next example of open loop control system is traffic signal. A traffic flow control system used on roads is time dependent. The traffic on the road becomes mobile or stationary depending on the duration and sequence of lamp flow. The sequence and duration are controlled by relays which are predetermined and not dependent on the rush on the road. Now we will see closed loop control system. A system in which the control action is somehow dependent on the output is called as the closed loop control system. Now we can see in the block diagram, input is there to the process, and our process is performing or processing that input, then we are getting the output. Again, when this again from the output that signal is there, we are taking that signal in the feedback element, therefore feedback element provides feedback to the input. This process will continue until output will be equal to the input. Now we will see certain examples. Automatic electric iron. This is the example of closed loop control system. Heating elements are controlled by output temperature of the iron. Now we are knowing that in case of automatic electric iron, there is one knob is there, this circular knob. We are setting that knob, and when the temperature reaches that particular temperature in the electric iron, automatically supply is cut off and that temperature is maintained. Again, if suppose temperature will decrease, again that supply is made on and electric iron heats that coil, and again temperature reaches to the predefined temperature. Therefore this cycle goes on continuing. Therefore this is known as closed loop control system. See that this desired time is there, timer, heating element, heat, we are heating the clothes means we are ironing it, actual dryness. Therefore again feedback sensor is there, it is giving some error signal to the timer, electrical energy is there. This process goes on continuing till the desired temperature is reached. An automatic sprinkler system. An automatic water sprinkler system has been ordered by a farmer. The system must have sensors that detect dry weather and turn on water sprinklers to water valuable crops. Here input. How will be the dryness of the soil be sensed? Perhaps an electrode can be used. Process. What devices will be needed to control the output? A computer could monitor incoming data and control the output. A simple program will be required. Output. This may be a sprinkler device which is turned on when the computer detects the need for water. Feedback. Feedback is constant as the computer continually checks the moisture level of the soil. The moisture sensors detects when the soil is dry. The Darlington pair is a simple electronic device that amplifies the signal sent by the sensors so that the computer can read it. Without the Darlington pair, it is possible that the signal from the sensor could be too weak to be read by the computer. This would mean that the sprinkler system would not be turned on. When the sensor determines that the soil is moist or damp, the signal to the computer ends and the computer turns off the sprinkler. This is called feedback. It is shown in this block diagram and this another block diagram also. Sensor system is there, it senses. Then some Darlington process is there, it is known as process unit. Then output is there, solenoid. Again feedback is given to the sensor system. Means like this control system works, closed loop control system works. Another example of closed loop control system, we can say that our in mechanical engineering, that is computer numeric control machine, that is CNC machines, which are there in our workshop. Now you are knowing that suppose a bar is there of 100 mm diameter, we have to reduce that bar to the 50 mm diameter. Now we have to make some program, we have to feed that program into the machine. Now when we'll run that program and when we start doing the job, what we have to do, just you have to insert your job in the chuck, you have to press the on button. Now the turning process will continue till diameter is reached up to 50 mm. Suppose at first cut the diameter is reduced to suppose 80 mm. Again output is that from the output signal, feedback element takes the signal and it processes that signal and it gives it to the input. Then again, what is our input? Diameter should be reduced to the 50 mm. Again input is compared with the output. Again it is given to that signal is given to the process. Again process means our turning action. Then tool takes the cut and turning action takes place. And again suppose diameter is reduced to 70 mm. Again feedback is given to the input, that is input feedback signal. Therefore again it is given to the machine or controlling elements. Again tool takes the cut. This process will goes on continuing till the diameter of the bar reaches up to the 50 mm. Therefore this is also known as closed loop control system. Now we will see difference between open loop control system and closed loop control system. Open loop control system. Any change in output has no effect on the input, that is feedback does not exist. Closed loop control system. Changes in output affects the input, which is possible by use of feedback. Output measurement is not required for operation of system in open loop control system. In closed loop control system, output measurement is necessary. Feedback element is absent in open loop control system. Feedback element is present in closed loop control system. Error detector is absent in open loop system. Error detector is present in closed loop control system. It is inaccurate and unreliable in open loop, that is open loop control system, while closed loop control systems are highly accurate and reliable. Open loop control systems are highly sensitive to the disturbances. Closed loop control systems are less sensitive to the disturbances. Open loop control systems are highly sensitive to environmental changes. Closed loop control systems are less sensitive to the environmental changes. In open loop system bandwidth is small. In closed loop control system bandwidth is large. Open loop control systems are simple to construct and cheap. Closed loop control systems are complicated to design and hence costly. Open loop systems are generally stable in nature, while in closed loop control systems stability is a major consideration while designing. Open loop control systems are highly affected by non-linearities. Closed loop systems, there is a reduced effect of non-linearities. Examples of open loop systems are coffee maker, hair dryer, washing machine, traffic lights, that is traffic signal, etc. Examples of closed loop control systems are guided missiles, servo voltage stabilizer, electric iron. Again from mechanical engineering you can give the example of computer numeric control machine. Now this is the difference between open loop control system and closed loop control system. Now we will see some modern control systems which are used in practical applications. First application is manufacturing. Manufacturing is being revolutionized by computer controlled machines. The desired path of the cutter is pre-programmed into the computer, that is in the microprocessor. The actual position of the cutter is determined by an encoder. The desired position is compared to the actual position to determine the error. The actuating signal causes the cutting tool to move so as to reduce the error. Computer controlled machines can manufacture complex shapes much more accurately than was heretofore possible. A program can be written to manufacture an entire piece. Now this CNC control machine already I have explained. Therefore same examples has been shown in the image. Diameter suppose you have to reduce to 100 to 50 mm. Therefore this tool is there. It has been shown in this image. Therefore tool will take cut till the diameter of the bar reaches up to the 50 mm. Another example of modern control system is space shuttle. Now we are knowing that in our India, ISRO is the organization who is launching satellite in the space. Therefore, you must think that some control systems may be used to place that satellite into the orbit. Therefore, these are nothing but modern control systems. Therefore, space shuttles is the example of modern control system. That is GSLV, PSLV, Geo Satellite Launch Vehicle, Polar Satellite Launch Vehicle. These are the examples of the modern control systems. Space shuttles have many important subsystems including orbital maneuvering system, the reaction control system, electrical power, hydraulic power, environment control, and life support system and thermal protection. Another example of modern control system is our engine control systems for a modern high performance jet engine. Now you are knowing that aeroplanes are there. We are operating, that is the pilot is operating the aeroplane at different heights with respect to the earth or with respect to the ground. Therefore, these modern control systems are used. The engine control system for a modern high performance jet engine incorporates many subsystems which perform automatically to ensure the safe, efficient operation of the engine. For example, under certain conditions, a jet engine can stall. The control system senses these conditions and automatically prevents the engine from running at a condition that would cause stall. In case of this aeroplane also, these modern control systems are used. When that aeroplane has to land, that signal is given to the airport, that some station is there, controlling systems are there. Therefore, every time that pilot asks whether he has to land aeroplane or not. Now suppose that aeroplane is at a height of 1000-meter height with respect to the ground. Directly that aeroplane is not coming from 1000 meter to 0 meter, that is to the ground. First of all, he has to take the aeroplane up to 800 meter height. Again, he will take aeroplane at a 600 meter height. Again, he will take at a height of 400 meter. Again, he will take at a height of 200 meter, and slowly he will land his aeroplane on the ground. Therefore, to control all these actions, these modern control systems are used. Therefore, same I have explained, at higher altitudes the air is considerably thinner. For the same amount of fuel flow, the air-fuel ratio would decrease considerably with altitude. The engine control system automatically compensates for changes in altitude. The altitude means height. The control system also controls the nozzle jet area. This affects thrust. The position of the inlet guide vanes. This directs the air into the compressor for the best angle of attack, etc. Next is our robotics. Now you are knowing that robots are used in the manufacturing industry, also in hotels, everywhere now we are finding in the robots. Now, in case of robot, these control systems are used. Robotics involves design, construction, operation and use of robot. The goal of robotics is to design intelligent machines that can help and assist humans in their day-to-day lives and keep everyone safe with the help of control systems. These robots can be used in various fields like industry, medical, space and many more. Now in the image it has been shown that robots are used for doing assembly operation. Similarly, that Asimo robot is there. It is developed in Japan. Sometimes now in future robots will work in hotel also to take our orders. Also they will give us or they will serve us also. Therefore this robotic system is nothing but modern control systems. In case of robotics, artificial intelligence is used. Next is the microprocessor. It is used in our computer or maybe in laptop or maybe in our mobile phones, maybe in tablets. Microprocessors. When the comparator is a piece of hardware such as a thermostat or a governor. The equations that describe the operation of the hardware are part of the control loop. Such controllers are referred to as the analog controllers. The use of microprocessors is becoming increasingly popular in control systems. The microprocessor is in effect a digital computer and is programmed to yield the relationship that the designer desires. The microprocessor thus provides a flexibility that is not possible with analog type controllers. With a microprocessor, a design change is accomplished by a simple change in the software, whereas with an analog controller, a design change necessitates a hardware change. Because the microprocessor requires digital signals and the system to be controlled requires analog signals, the use of a microprocessor necessitates both an analog to digital converter or digital to analog converter. Now another example of modern control system is Humvee, the high mobility multi-purpose wheeled vehicle known as Humvee is a family of light four-wheel drive military trucks and utility vehicles produced by AM General. Now you are knowing that in case of military operations also, some vehicles are used to launch missiles. Therefore, in the vehicle itself, that direction of the missile, also at what distance that missile should be fired, it is controlled in that vehicle itself. Therefore, these are the examples of the modern control systems. Therefore, we will stop here. If you are having any questions, you can ask. Thank you very much.